Hey, good evening, everyone. I'm waiting till everybody gets signed in before we get started, but welcome tonight to our March 2024 Wild Ones River City meeting. I hope everyone has enjoyed the lovely weather today. Feels like spring for sure. All right, you guys, I'm going to get started. As I said, welcome to our March 2024 Wild Ones River City program. My name is Linda Gary, and I'm the president of the River City chapter for this year. For those of you who are new to Wild Ones, we are a local chapter of a national organization. We are a nonprofit that focuses on increasing biodiversity through native plant landscaping. Our stated mission is to connect people and native plants for a healthy planet. Our program tonight is on jumping worms, and I'm so excited to learn about these new creatures. I hadn't heard that much about them before. This last week, when I told someone who doesn't know that much about native plants and invasive species about this program, they just started laughing hysterically at me at the thought of jumping worms. So I'm really glad to be getting some good information that I can share next time I have that conversation. In our past Zoom webinars, we've had folks from West Michigan, but also from around the state and from other states as well. And so sometimes it's fun to put your location in the chat box. If you want to do that, it's kind of fun just to see where everyone is watching from. Before we move into our program, I want to give a plug for being a member of Wild Ones River City. Most of our events and programs are open and free to everyone, and that is exactly as we want it to be. We don't want there to be any barriers to anyone getting information about native plants and the wider world of restoring ecosystems. Now, there are some advantages to being a member of Wild Ones. Being a member enables you to support an organization that you believe in, and it's also a way to help provide funding for the many free events and opportunities that we offer. As a member, you also are able to access some web pages on the Wild Ones website, the national one, as well as our local River City one, that are for members only. We also have a few events during the summer and fall that are for members only. Our garden walkabouts, which are like an open house hosted by Wild Ones River City member to showcase their garden at their home, are for members only. And so if you like to see what other folks are doing to their yards with native plants, this is a great way to check out some different options. Another reason to join, to become a member, is that Wild Ones River City members also have an early option to order plants at our annual native plant sale in July. We always try to have enough plants for everyone to get what they want, but we sometimes do run out of the more popular species. So if you're a member, you're able to order early, and that's not a problem. So on our website, there is a link where you can join. You join through the National Wild Ones, and then you put in River City as your chapter, and that will connect you to us here. If you're not in the Grand Rapids area, there are lots of other Michigan Wild Ones chapters, as well as chapters in other states. So I hope you're able to find one near you. So before we introduce our speaker, there's some housekeeping items I want to remind you about. There's lots of buttons at the bottom of the screen, but two buttons I just want to call your attention to. The chat button is where you can type in comments during the presentation, and that is also where we will post websites and other links that correlate with the program. And there will be a link to Shelby's resources, or her whole presentation, so you don't have to remember everything tonight. The Q&A button, which is also at the bottom of your screen, is for you to type in questions that you would like Shelby to answer at the end of her presentation. Oh, and lastly, you will receive an email in a couple of days with a link to the YouTube recording of this program. You're welcome to pass it on to anyone who you think would enjoy it. All right, so that's all I've got for now. Linda Schuster, our program committee co-chair, will now introduce our speaker, Shelby. Linda?
Thank you, Linda. So I do have the pleasure of introducing our speaker. Shelby Nicole Lane-Clark is an applied ecologist. She holds a bachelor's degree in wildlife biology from the University of Michigan-Flint and recently graduated in 2023 with a master's degree in forest ecology and management from Michigan Technological University. Her master's thesis focused on the impacts of introduced earthworms on sugar maple forests in the Great Lakes region and the implications for sugar maple sap chemistry. She now works with the Detroit Zoological Society doing environmental-based outreach to high school students in her community. We're thrilled to have Shelby here to share her expertise. Welcome, Shelby.
Hi, thank you, Linda. I appreciate it so much. I'm so excited to be here tonight and to be able to share with everyone about jumping worms, which is something like other Linda was saying earlier, not a lot of people have heard of, and there's a lot of common misconceptions that we're going to try and clear up tonight. So I am going to turn off my video just to make sure my internet participates with me tonight, and we're going to get started. So let me make sure. Briefly, I'm going to go over what our agenda is going to be for this evening. So we're going to get started with introducing everyone to what jumping worms are, kind of looking at morphological features, how you can identify them, how you can kind of make sure that you're telling them apart from other earthworms that are present here in Michigan. Then we're going to get into how earthworms got introduced in the first place. A lot of people are always very surprised to hear that there are no native earthworms, especially in the UP, but also in a lot of the Lower Peninsula of Michigan. The ones that were pushed out by the glaciers are just now starting to come back. So a lot of the ones that you see are not actually supposed to be here. So we're going to talk about that, and then we're going to talk about how jumping worms got introduced as well. Then we're going to look at the ecological impacts of them as an invasive species, especially particularly in sugar maple forest, which is where I did my master's thesis work. And then we're going to get into the really positive parts, how we can help as environmental stewards, what we can do personally and as a whole as humans. And then we will open it up for questions after that. So what on earth are jumping worms? I know it sounds like a silly, crazy name, but they're actually a very, very problematic species, a couple of species actually, that have been introduced and are causing a lot of havoc in our hardwood forests in the Great Lakes. So before I introduce you to jumping worms, I want to briefly talk about how not all earthworm species are the same. A lot of them may look very similar, but they actually do different things in the soil. So there are three main categories called ecotypes. The epigeic ones are kind of the least concerns. Those are going to be very common as bait worms. Red wigglers are a common species of those. Those stay very superficial at the top of the soil. So they stay kind of in the leaf litter. They don't do a whole lot of mixing of the soil horizon. So they're kind of the lowest impact and the most widespread that you see around the state of Michigan. The next ecotype is called endogeic. And so those are kind of your middle range, your just right porridge kind of the earthworm species. And so those kind of stay in the upper levels of the soil, and they have horizontal burrows. So they kind of do a little bit of mixing of those horizons. It's not as bad impact as the anisic earthworms. So those are your night crawlers. So the really big ones that you see coming up onto the sidewalk when it rains, those ones dive super duper deep down into the soil, up to 3 meters. And they do a ton of mixing. They pull all the organic material down from the surface layer, the leaf litter and everything, super deep down, and then they mix all the mineral horizons as well. So those are kind of the different ecotypes we talk about when thinking about earthworms. So jumping worms are called epiendogeic. They're kind of right in the middle of the epigeic and endogeic ecotypes. And so they kind of stay in the surface litter, but they mix it down into the top 2 or 3 horizons of the soil. So these guys here are, depending on the species and the age of the individual, between 1.5 inches and 8 inches. So they can get quite big. Some defining characteristics are this clitellum here, this kind of feature on their body that on a lot of worms looks like a band-aid, is actually flat, so it doesn't raise up over the rest of their body. It's also very smooth, it doesn't have any ridges on it, and it tends to be quite light in comparison with their body. It tends to be that like milky white color, maybe a little grayish. And some ways that you can tell the difference between jumping worms, also known as crazy worms or snake worms, is they jump. They are very, very aggressive in their movements if you handle them. And they also excrete this really gross, thick, yellowy mucus that can irritate your skin as well. I have heard jumping worms be referred to as earthworms on steroids because they are very good at what they do. They are very, very enthusiastic workers when it comes to mixing the soil horizons. And so that's why there's such a huge concern when it comes to them as an invasive species, because while all invasive earthworms are a concern, these guys are very, very, very active. So they tend to cause detrimental impacts that are on a greater scale and on a faster scale than other species. So here is kind of a zoomed in shot. This is another kind of species that has that more grayish color clitellum, so it's not as obvious, but again, you can see that it is there and it is flat to the body as opposed to raised up. And this is what the soil looks like after jumping worms have been introduced. You can see that instead of lush leaf litter and the humus layer, that really rich topsoil that you get in the forest, it's all bare mineral soil, and it is very, very clumpy and dry. And so I'm going to talk a little bit later about why this causes issues in our forests, because this is a huge change from what we normally see in the hardwood forests here. So how did they get here? So earthworms as a whole were completely extirpated or removed during the last glaciation. So the glaciers that came down from the areas of Canada kind of acted as like a bulldozer, like a big shovel, and they just pushed all of the soil out ahead of them. And so as they retreated, it was just bare bedrock. And so as succession kind of took place, as soil started to reappear and new organisms and plants started to come back, they all lived for 12,000-ish years in the complete absence of any earthworm activity. And earthworms are what's known as ecosystem engineers, and so they have a huge impact, kind of like beavers are also known as ecosystem engineers. They have a huge impact through their activity on their ecosystem around them. And so when there's not any earthworms present, those plants get really used to the conditions of the earthworms not being present. So during colonization and during like the fur trade, European settlers did a lot of commerce in this region, especially throughout the Great Lakes. It was great for shipping. And so as ships came over from England and other European countries, they were weighed down with ballast, and the ballast was soil so that the ships could come over, dump that ballast along the shorelines, and then fill up with goods so that they could sail back over. Well, the earthworms were just in the soil. They had no idea what was going on. And so suddenly they're in this new place where there's this ecological niche that's not being filled. And they're like, awesome. They're going to do a really, really good job of filling that empty space. And so that's how they originally got introduced. And now today, they continue to be spread around through human activity, building of roads, off-road vehicles, hiking, they get on your boots, or their eggs can get in your boots, and then you get spread around that way. Horticultural material is a big way that they get spread around. And so not only was their introduction entirely human caused, but now today they're spread because they move really slowly on their own. They're mostly spread through human activity. So jumping worms are a relatively recent introduction. They are typically in the Amynthas and Metaphire genera, And they were found first in Michigan in Oakland County, which is actually where I live, in 2008. But since then, it's believed that they are likely widespread throughout the Lower Peninsula. Thankfully, they have not made it to the UP as of yet, but in 2013, they were found in Wisconsin. And so kind of sandwiched in the middle, it's only a matter of time. The reason we're not totally sure the extent of spread is because they're hard to see, right? They're underground, and there's not a widespread movement of kind of monitoring where they're going to. They are now found in 34 states throughout the US. And part of why they're such a problem and why they spread so easily, but also without going noticed, is they're what's called parthenogenic, which means that they can reproduce asexually without a mate. So one worm can turn into many worms without any other interaction with any other worms. One of the biggest ways that specifically jumping worms are spread around is through greenhouses. So plants that are moved around in the US or brought in from overseas, typically in the Asian countries, especially ornamental plants, have these worms in the soil. And as the plants are displayed in the greenhouse, the worms escape and can get into the soil that way. And plus, when people buy the plants, they get planted into their gardens. So this is a map from 2021 showing the spread that we know of jumping worms. I'm sure, I mean, it's been 3-ish years since then, so they've likely become more widespread, and there's likely a lot of spread that we just aren't aware of because of lack of monitoring. So let's talk about the bumper part. So ecological impacts of earthworms overall, but specifically jumping worms. So some big commonly held perspectives and kind of pushback that a lot of earthworm researchers receive is, well, they've always been here. And while that may seem true, they arrived simultaneously with European settlers and rapidly became widespread. So it's kind of, they came along with white settlers and they've been here ever since. So it's been hundreds and hundreds of years that they've become established in the US. Another reason is they're a popular educational tool. They're great for young learners. And so things like composting, earthworm life stages, and even as kids get older, dissections, they're really, really popular and important educational tool for learning a lot of different biology. Another thing that I've heard is that they're really good for gardens, and that's true. This whole situation is all about context. So the use of worms to create fertilizer is called vermicomposting, and it's actually super duper beneficial for farming. So for crop systems, which are high turnover, rapid nutrient cycling systems. You think that every single year these crops grow up, they pull all of the nutrients out of the soil, you have to supplement those nutrients. And so earthworms are really great at cycling nutrients through systems and increasing the availability of nutrients. And so that's really great in that context. But in forests that have evolved and grown for tens of thousands of years without the presence of earthworms, that's where you start getting issues. Forests are very slow cycling systems. The leaf litter falls and their fungi driven decomposition is very slow. And so as those nutrients over time very slowly cycle through the system, that is what those plants are used to. And once you get the earthworms in there, they speed that up, which we're going to talk about a little bit. So very briefly, I feel like it's important to talk about the different soil horizons, just because I'm going to refer to them in this way. And so the O horizon, which I'll refer to a lot, is that very top layer of leaf litter and organic material. It's very coarse organic material, broken down leaves, that kind of stuff, dead plant material. And then the A horizon is going to be that topsoil, that rich black dirt that you find in the forest. It's very, very thick and has a lot of fine root material in it. And then the E horizon is the next one that's really important. That's where you have a lot of loss of nutrients. It tends to be a very pale grayish color because that's where the nutrients are kind of, and the minerals are running out of. And then below that is the B horizon, and that's the sedimentation layer. And so that's going to be where those nutrients and minerals that come out of the E horizon collect into. And it tends to be very reddish in color because of iron. And then C horizon here in Michigan tends to be either limestone or bedrock, but we're not going to worry about that today. So, as I was talking about earlier, earthworms are known as ecosystem engineers, which means they come into a system and they, through their activity, change it for their benefit. Again, like I was talking about earlier, they are filling a previously unfilled niche in our northern hardwoods here in the Great Lakes region, which are dominated by sugar maple. Sugar maple, a lot of stands, especially in northern Michigan and the UP, tend to be pure sugar maple stands, and that's what they're managed for timber. And sugar maple leaves are the perfect food for earthworms. They absolutely adore them. They're very, very high in nitrogen. They're very easy to break down, and they're very high in sugars as well. So basically, it's like a perfect buffet provided for these earthworms as they continue to be spread. And the way that we utilize our forests here in Michigan and in the Great Lakes region tends to be a lot of off-roading and a lot of hiking, as well as a lot of logging. And those are all very, very notable ways that earthworms are spread. And this picture here was taken in a pure sugar maple stand during my research. It was one of my favorite sites because it was just so lush and green. So earthworm impacts on soil horizons. So here on this side, you can see 3 soil cores that I took along an invasion gradient during my master's research. So this top picture here, you can see is an intact soil. So that has, you can even see in the background how much leaf litter, coarse woody debris. Underneath that is very, very rich, spongy. It feels almost like moonwalking because it's so bouncy in the forest. And so you can see here at the top of that you have that layer of really, really rich, dark topsoil. You have that classic alluviation, that's leaching layer where the nutrients run out into that nice red B horizon. But as you go down in these pictures, you can see that those start getting mixed. And so that middle one was right at the very middle of the invasion gradient. And then this bottom one here was at the very end of the invasion gradient, where it was an established long-term earthworm population. And so what they do is they actually consume and bury those O and A horizons, those top 2 layers. And as they do that, they're mixing those layers down into those mineral layers. They're pulling that organic material so that it's no longer available at the surface. And so a lot of times you'll see a short-term nutrient pulse and increase in productivity in stands that have had earthworms introduced, especially complex, like many species and ecotypes present. You'll see a pulse in the productivity and the sugar content of trees in those areas. But over time, it's a long-term negative impact because, again, there's not a ton of input of leaf litter, at least not enough to be meaningful in the long term each year. And so in the fall, the leaves will fall. And then in the spring, the earthworms will immediately consume all that organic material and then leave another exposed mineral layer of soil. So this leads to changes in the biogeochemistry. So the form of nutrients, they are typically more mobilized so that they leach out faster. And so that's really the big impacts of earthworms on soil horizons. The main cause of those changes, aside from the mixing, is the texture of the soil is changed. And so, like I was talking about earlier, these castings are that main indicator that earthworm activity is present. And it looks like coffee grounds. It's really clumpy. It's very hard, but it's also very aerated, porous soil. And so it dries out faster. Water leaches out very, very quickly, but also more air gets into layers that normally aren't exposed to air. And so that increases the rate of decomposition in the soil. And that is what really causes that increase in cycling rate of nutrient loss. So as things decompose, they leach out of the system faster. They also get released as emissions because of their mobilized phase. And so we've actually seen an increase in greenhouse gas emission in forests that have been populated by earthworms. So all of this has major disruptions on the communities in the soil. And so if you think of the soil as the foundation of an ecosystem, especially in our forest ecosystems where it's such a fungus-dominated, very macroinvertebrate rich soil community, you start to see what's called a trophic cascade. And so it's a bottom-up kind of collapse of our forest ecosystem. So if there's not the forest plant communities, which we'll talk about in a second, earthworms actually decrease the biodiversity of plants in forests. You lose the food source for a lot of organisms. So those macroinvertebrates provide a lot of food. So insects, mollusks, that kind of thing. So like snails and slugs. And then anything that eats those, we see significant declines in biodiversity as well. So salamanders, songbirds, even decomposers. So like we see a decrease in fungus biodiversity. So basically those earthworms come in and what's called side swiping. They do side swiping in these forest food webs. So as I was saying briefly, because of the loss of the O and A horizon, which is basically the foundation for the seeds to grow, provides the safety and the protection and the food that these seeds need to thrive. And the earthworms get rid of that. And so a lot of plants aren't able to germinate on that bare mineral soil. So we see this reduction of native herbaceous vegetation, and a reduction in recruitment into the understory. And so not only is it the kind of herbaceous vegetation, but it's also the seedlings and saplings of trees like sugar maple that rely on that duff layer, that O and A horizon. And you can see in this picture here that my advisor during my master's took of an unimpacted forest floor versus an impacted forest floor. All of that sugar maple regeneration was pretty much gone. Instead of walking through this lush green, very mosquito-y filled habitat, we were walking on bare mineral ground and there was just barely anything growing. Something that we've also seen is an increase in invasive species of plants coming in because they are very competitive in this fast nutrient cycling, bare mineral soil kind of environment. And so you'll see an increase in things like buckthorn, barberry, autumn olive, and things like that coming into these ecosystems along with the earthworms. So this is kind of a little summary image that I put together for my master's, which is why this little remnant of sap chemistry is in there in the middle, because before my master's, we didn't know. But you can see on this side here, all this regeneration, you have those distinct soil layers, a lot of biodiversity, and then it turns into kind of the roots are being exposed of the tree, you don't have that regeneration, decrease of plant and other animal biodiversity, and also a decline in the health of trees overall, mostly sugar maple, but we were seeing it in all kinds of different species of trees. So that was a bummer, but let's bring it back to being kind of a positive, what can we do about this as environmental stewards kind of situation. So an overall management of earthworms and jumping worms specifically, if we manage human activity, we're going to more effectively manage the spread of these organisms. And so increasing the monitoring is very important. As I said earlier, we really don't know how widespread they've become. And this is true for all earthworms, but especially jumping worms because they're so new. Citizen science is a really important aspect of this because individuals going out and doing forest floor assessments, which we'll talk about, and doing mustard pores, which are super fun, which we'll talk about as well, and documenting this spread and documenting which species are found where is really, really important moving forward to being able to effectively manage for these organisms. One of the biggest, most important things is restricting and regulating travel and road building into vulnerable areas. So I mentioned earlier that building of roads, especially when you bring road fill for actually laying the foundation for the roads from other areas, you're just moving soil around, right? And so it's like just like the ship ballast that we talked about earlier, that soil is coming in and it has all sorts of organisms in it, including earthworms and their cocoons, which are their eggs. And then that's a new introduction. And so making sure once we know which areas are vulnerable and are currently not inhabited by these organisms, we'll know kind of where we need to stop travel or road building, or where we need to regulate cleaning tires and cleaning boots and that kind of thing. Another really important aspect is like this today, increasing education through outreach programs like this for gardeners, farmers, anglers, and really just anybody. Like Linda was saying, she had someone like laugh because this is kind of like it seems silly and it seems not true that earthworms can cause these problems, but the more we increase education through programs like this, and you all go out and spread the word and give the information that I've given to you today, the more people will know and the more they can be informed in their actions. Like I mentioned, washing the wheels of machinery and off-road vehicles, so whether it's logging, construction, if you have an ATV or anything that goes off the road, making sure that between places that you go, you're cleaning off the tires. So putting in wash stations is another really good management move that can, especially in vulnerable places, making that more accessible so that it's not only on the individual, but they have that resource available that they can use, and it makes it easier. The easier things are, the more likely people are to do them, right? So this picture up above is also a bait dumping spot. So being cognizant of dumping your bait if you're an angler, making sure that you're doing it responsibly, sending them to a landfill, or dumping it in a sealed off kind of area like this is another really good way to make sure that you're being a good steward. And then again, this is all the legal side of things, right? Policy, always very exciting, but restricting and regulating the import of non-native species. This is just a very broad thing to say, right? Like we need more of that, but especially for things like horticultural material, making sure that mulch and soil and plants are treated to prevent the introduction of earthworms and jumping worms, making sure that bait that's coming in is species that are already present is even a good compromise. So making sure that new species aren't being brought in as bait. Unfortunately, this is another bummer. There are no large-scale solutions for eradicating and managing for earthworms. Because they're in the soil, because we don't know how widespread they are, it's next to impossible, if not impossible, to treat all of the soil. And another thing we need to think about is collateral damage. It's going to be very site specific whether there's native earthworms in an area, because there are some. So like south of Michigan, like Indiana, Illinois, Ohio, there are native earthworms that are now being outcompeted by these introduced species. And other organisms in the soil, like macroinvertebrates and all those other important members of our forest communities, we don't want to kill them. And those could end up being collateral if we do a large scale heating treatment, for example. A lot of vermicides are expensive and they're very labor intensive to apply. And they're not always guaranteed to work because a lot of earthworm populations can be very spotty based on where they were introduced. I mentioned before that they don't move very fast. So if there's just a small area that we don't know about because there's no effective monitoring at the moment, then trying to figure out where all those spots are for treatment would also be very difficult. Some small scale treatment options that can be done on like a personal property. They are expensive, but you can remove the topsoil entirely and have it replaced with treated topsoil that does not have earthworms in it. Like I said a few seconds ago, you can heat treat the soil. I can't remember the exact temperature, but I know it is for a 3-day period that heating needs to be applied for things like mulch or soil, but you can do that to your entire property over time. Application of vermicide is another one, and then electrical shock, which may seem extreme, but it's very effective for small scale jumping worm infestations. And so those are really the kind of eradication or treatment options that we have at the moment. And none of them are very effective on a large scale. Back in 2005, a study by Gundale et al. Said that between 91.7% and 98.9% of sugar maple habitat will be invaded within 100 years. And that's pretty much from building of roads and harvesting timber. So while it may seem like a huge bummer and maybe even hopeless, there is still actions that we can take, like I mentioned on the previous slide, to help prevent and slow the spread into areas that are not currently impacted. So on an individual level, what can you do to help? Be aware, spread the word. Like I said earlier, communication and outreach on this kind of thing is the most important thing. Disposing of your bait, making sure that you use boot brushing stations or boot washing stations. If you have the ability, checking your mulch and potted plants for little hitchhikers that might be in them. And then if you have the ability, only going for treated mulch and topsoil or treating it yourself. And then keeping out an eye for new earthworm activity and reporting sightings of jumping worms to MISIN, which is the Midwest Invasive Species Information Network. There is a wonderful app that you can use to report sightings. And if you're wondering how you can report sightings of earthworms that live under the ground, I have some recommendations for you. So at the end of this presentation, I have attached the instructions for forest floor impact ratings, which through my master's, I was able to help validate that this rating scale is just as effective as doing actual physical mustard pores and going through and identifying earthworms individually with a microscope, because you have to look at their tiny little mouth parts to be able to tell species apart and look at little hairs that are on their bodies, if they're clustered or if they're singular, which I will say that I spent an entire day once, 13 hours, identifying over 500 worms. So that was a very exciting day. But you don't have to do that because we have this really handy dandy forest floor impact rating scale. And so it's a 1 to 5 scale. It's an inverse scale. So 1 is the highest impact and 5 is the lowest impact. And you can use that to look at the forest floor or the soil in your garden and kind of assess how much of an impact earthworms are having there. You can do something called the flip and strip, which is basically you just flip over logs and rocks, and you can count and kind of do a quick ID of the earthworms that you see under there, because oftentimes if you're gardening and you flip over a piece of wood, there's worms there. Digging tends to not be the best option because earthworms are very sensitive to vibrations in the soil. So if you're digging around, they tend to run away or go deeper down into the soil, so that then you'd have to really be digging to find them. Something called earthworm middens. So middens are these kind of clumpy tunnel entrances to the burrows that they create. And you'll know that they're different from the rest of the soil because it tends to be like fine roots and seeds and soil and other organic material and leaf litter all clumped up using mucus, which is gross, but those are the entrances to night crawler dens. And so each midden is associated with one night crawler. And so if you count those, you can kind of get an idea of the impact of anisic earthworms in your garden or in the forest that you're monitoring. And then doing a mustard pour is my favorite thing to do. It's really, really fun to do with kids, especially because it tends to happen very, very fast, and you get lots and lots of worms. So the instructions on how to do this is you use ground mustard, which you can buy just at the grocery store or at a co-op, and you mix it with water. So if you have a gallon jug from like a jug of milk, you fill that up with water and you add about 1/3 of a cup of mustard powder, and you shake it all up. And the reason this works is because mustard is irritating to the skin of the earthworm. They're basically one big mucous membrane. And so if you think if you've ever gotten mustard like up your nose, it burns. And that's how it feels to the worms. And so you mark a 1 by 1 foot plot on the ground, and then you'll shake up the jug, and then you'll pour half of it. You set a timer and you wait 5 minutes. And these earthworms are just going to come shooting up like Dawn of the Dead. You're going to get tons and tons of worms depending on the area that you're in. And so they'll come up, you can grab them, you put them in a little tub, and then you'll do it again. So after 5 minutes, you pour the second half, you wait another. And the reason you want to do 2 pours is because that will allow the mustard water to get really deep down into the soil where those anisic earthworms tend to stay, and you'll get a bit of a more accurate population assessment. And so once you have all of your worms, you'll pick them up off the ground, you'll put them in a tub, you can kind of class them. And I will share another resource that I have that helps with the identification of earthworms. So that is really user-friendly, really easy to use, that I can add on to the resources list. But if you ID them, you can kind of get an idea of what ecotypes you have present, what their impact is, and kind of how much you need to be concerned about the impact of earthworms in your area. And then this here is that impact rating scale, and it comes with pictures, which is very helpful. Here you can see much more of an impact. It's hard to see in this picture, but the castings, those coffee ground textured castings. And then on this side, you have a nice intact forest floor with lots of plants, lots of leaf litter. And then down here is that description. And like I mentioned earlier, I validated this scale using actual earthworm pores, and it is 1-to-1 exactly comparable. So if you don't have the ability to do an earthworm mustard pour, which I do highly recommend doing at least once, especially if you have kiddos in your life that might have a fun time getting their hands dirty in the soil, this is a really good tool to use as an alternative. So these are some resources that I have. The links should work in the PDF that I shared with everyone. And then I've also added my contact information. I'm going to do a shameless little plug here for a second to check out my thesis. My thesis was a 2-part thesis, and one part was looking into the impact of non-native earthworms on sugar maple sap chemistry, and kind of the implication that's going to have for the maple syrup industry, which is really big, especially in the Northeast, but here in the Great Lakes region as well. And then the other part I talk about kind of the implications of the language we use in the field of invasion ecology. So keep an eye out. I have 2 publications coming out. One just got accepted, and that's going to be my Shifting the Language of Invasion Ecology, Two-Eyed Seeing as a Framework for Discourse Regarding Introduced Species. And then later this year, I will have, after doing a lot more statistics that I have to do, I'll have my SAP chemistry paper coming out. So keep an eye out. So with that, that is everything that I have. So if anyone has any questions, I would be happy to answer them.
Well, thank you, Shelby. That was just wonderful. And we do have some questions in the Q&A. So the first one is, why is jumping worm infestation greater in the Northeast as compared to the Southeast US?
So that is a great question, and I don't know the exact answer, but based on what I know from other introductions of earthworm species, there is greater presence in the place where they were originally introduced. So I believe they were originally introduced in New York, and so they've been spreading out from there, and I'm sure for a while they went unnoticed, and so there was no management. So that's likely why they're more present there as opposed to elsewhere.
Okay. Well, the next question, will anything kill the cocoons in the soil so jumping worms can, but I don't think the person finished the question.
Heating. Heating is the best thing you can do for cocoons in soil and mulch. And I will have to find the exact temperature. I forgot it. It is above 100 degrees. But I will have to look that up and I can share that out.
Okay, great. So somebody asked about if they see jumping worms, should they report it?
Yes, absolutely. Go through Missin. It's a super easy to use app. They also have a website if you don't want to download the app, and you can submit like a citizen science report on the sighting. And if you find them, the humane thing to do is to freeze them. So if you just put them in a baggie and put them in your freezer for like 3 days, I know it's probably weird to say put a worm in your freezer, but that is like the humane way to euthanize them.
Okay. So the next question, I'm confused about native earthworms. I thought you said they were eradicated with the last glaciation. Aren't common earthworms, aside from the jumping ones, all introduced from Europe? But you said that we don't want to eliminate native earthworms. Can you please clarify?
Yes. So I meant that in a context specific kind of situation. So there aren't any here in Michigan, but for other states south of the glaciation line, there are native earthworms as well as introduced earthworms. And so treatment options in those places would have to be kind of more nuanced to not have the native earthworms that are supposed to be there be collateral damage. Sorry if I confused anyone with that one.
The next one, the AJW don't have a white collar when first hatched. They get it later on in the summer, correct? And once they have hatched, does the white collar disappear? Do the worms die after spewing their eggs?
No, so they can reproduce numerous times. But typically earthworms are very, very hard to differentiate from one another as juveniles. And so if you have a young jumping worm, that's going to be very difficult to tell apart from other species. That one would have to be kind of an under the microscope situation. But multiple life stages can exist at the same time. So if you have jumping worms, you are very likely to see the adults if you do a mustard pour or if you do any sort of monitoring.
Okay, the next one, I try to kill all the jumping worms I see in my flower beds, but I know the eggs are so tiny that I can't see the eggs. Am I making a difference by at least killing the adults?
Yes, because one adult can make many, many more worms. So I would say to keep euthanizing them, because that is, aside from heating the soil and treating the soil, the best kind of management that it on an individual level that we can do.
Okay, great. The next one, should I in fact be trying to kill any and all earthworms that I find in my garden soil or homemade compost?
I would say no. It's more because the jumping worms are a more recent concern, that individual euthanasia can make an impact. Earthworms on their own are so widespread that it would be almost inhumane to kind of just like go out of your way to kill them, sadly. So I would say no, don't go out of your way to do that. But if you do see a jumping worm, put it in your freezer.
Okay, and the next question was, how do I kill jumping worms if they come out of the soil and I collect them? And I think you just said that again, right?
Yeah,
put them in the freezer.
You can also use ethyl alcohol. When I was collecting specimens for my master's thesis, that is what we did, because we needed fresh specimens to identify. So we did use ethyl alcohol, and I'm pretty sure you can use isopropyl alcohol as well. So if that's something that you wanted to have like a tub of, if you know they're in your garden and you want to be able to really quickly do that and then not have a bag of worms in your freezer, you could have a tub of like isopropyl alcohol and throw them in there.
Okay, does the mustard have an effect on the soil and other organisms?
So all soil microinvertebrates will come up to the surface as you do the mustard pour. I like to have a little tub of clean fresh water so that if like a beetle comes up or like a millipede or something comes up, I can just like rinse them off really quick and then like send them on their way. But it does not have an overall impact on the soil in the long term. So it'll be spicy for a day or two, and then the next rain will come and it'll wash it away. So it'll be all good.
Okay. Do you have any videos of jumping worms?
I do not personally. I did all of my master's work in the UP where there are not jumping worms. So I have actually never encountered one through my field work. So I don't personally have any videos, but I am sure there are many that I could find and share out with you all.
Okay. So we have a couple people who ask about how you heat the soil, and then one person also asked about how you electric shock them.
So the electroshock one is it looks almost like a Ghostbusters backpack. It's like a big battery that you carry around on your back, and it has like a grounding thing, and then you can stick a rod into the soil. I have also seen people do it with a car battery. If you want to do it that way, you get like a metal rod of rebar. Just please be careful. This is not me saying go out and just like hook a car battery to a piece of rebar. But there are people who do this treatment as well. And then the heating tends to be done, it can be done in a dehydrator, but that's on a very small scale. For a large scale, like a yard, you would have to go through like a professional company to do that sort of treatment. And I believe there are professional companies who do the electrification as well.
Okay. I thought it was research about a fungus affecting the earthworms and using charcoal.
Oh, if there is, I am not familiar with that, but that would be very interesting. Biocontrol would be a very viable option if there is something like a fungus or a pathogen that could come from like the native range of some of these earthworms and be introduced, but that would have to be done very carefully because of the, like I said earlier, the collateral damage in areas where there are native earthworms. You would have to be very careful about not introducing that pathogen to them. Biocontrol is tricky.
Mhm. Oh, how warm do I need to heat my compost to kill worm larvae?
I have to look it up, but I can share it out with everyone.
Okay.
That temperature has slipped my brain somehow. I had it earlier today and it's gone.
Okay. What would be recommended practices for plant swaps? Is root washing sufficient, or is it better to completely abstain? What would be telltale signs to look for?
So looking for individual worms in the soil, the cocoons aren't so small that you can't see them. And I can find pictures and share those out as well of what earthworm cocoons look like that you can look for in the soil. Bare root plant swaps are the best. So washing the roots and having bare roots on your plants before swapping them is the best thing you can do.
Great. How long do they need to stay in the freezer before they die?
3 days.
Okay. Do birds eat jumping worms?
I would imagine yes. Birds like the robin and the American woodcock are known to make a good feast out of earthworms if given the chance. So I wouldn't imagine, ooh, perhaps with the mucus, that might be a pretty significant deterrent. I know there are no natural specific predators of the jumping worms here, but I don't know if the mucus would deter birds from eating them or not, because it is gross.
So a couple of people mentioned they Googled jumping worms and they found some videos, a segment from Inside Edition. And in that same video, the person demonstrated the mustard method.
Yes.
Somebody was asking more about Missin and what the app does.
Yeah, so the app tracks reports. And so, like that map you saw earlier, resources like that rely really heavily on citizen science. So things like Missin, where individuals in the community go out and they spot an invasive species and they give the location, they take pictures. And so it's a really, really useful app for researchers to help track the spread of invasive species. So basically you go out, if you see a jumping worm, you use the app or their website to report where you saw the sighting, and you can add pictures to help validate that as well, so that someone can be like, yes, indeed, this is a jumping worm.
Right. And also just add that you can, any invasive species that you notice, so garlic, mustard, plants, it just helps us keep track of where these invasive species are entering.
Yeah, so it's definitely not just for jumping worms, it's for all invasive species.
Our composting company says they heat the compost to 150 degrees Fahrenheit to kill pathogens. So, and Mindy says,
that seems right.
but she doesn't know if it applies to worm larvae.
Yeah, because I know the heating has to be done for 3 days as well to kill the cocoons.
Okay.
So I will definitely look that up, the temperature, to make sure that people can validate that their compost is being treated.
Okay, great. So for my Wild Ones group here near Chicago, if someone has a small yard and wants to change out the topsoil, how deep do they need to go to remove the soil?
I believe it's at least 6 inches, but I would have to validate that. I don't want to give out confident, wrong information.
Okay. And another question, do moles eat jumping worms?
That is a great question. I am not a mammal person, unfortunately. I am woefully ignorant when it comes to mammal activities. I know that moles do eat regular earthworms, but then it comes back to, are they deterred by the mucus that they produce as a defense mechanism? And I do not know the answer to that.
Hey. Well, that's the last of our questions. So I'd just like to say thanks again to Shelby for her excellent presentation. And thanks to all of you for attending tonight. We hope to see you through Zoom on April 15th at 6:30 p.m. for a program on rain gardens. So Shelby, thank you again, and everybody else, have a nice evening.
Thank you so much again for having me. I really appreciate it.